Yesterday we watched that video of Darius Washington getting fouled at the last second of the game, so time is completely gone on the clock. They are 2 points down, and the only way that his team's gonna make this, to win this game is if he makes his foul shots. Now, he was fouled behind the three-point line, which means he gets 3 foul shots, which is kind of great because that means he could actually win this game in regulation, I think is what it's called, because I'm so sportsy. So what is the probability that he's actually going to win? What's the probability he's going to lose? And what's the probability they're going to go into overtime? Well, let's think about, remember at the end of the last video, we saw that his free throw average is 72%, which means he's making about 72% of his free throws. So you might think like, oh, well, it's a 72% chance, but not really, because there's lots of different options that could happen here, right? So what would cause him to win the game with his free throws? Well, he would have to make all 3 of his shots, right? We're just going to do that with like a little check mark. That is a really ugly check mark in the middle. Let's try that one again. Okay, so he has to make all 3 shots. What would cause him to lose the game? Well, if he missed all 3 shots, he would definitely lose the game, right? But what happens if he makes one of them but misses 2? He would still lose, right? Because they'd still be 1 point down. But this is not the only option, right? He could make the first one and miss the second and the third and lose. Or he could make the second one. Let's see, miss the first one, make the second one, and then miss the third one. That would also cause him to lose. What if he missed the first one, missed the second one, and then made the third one? That's another option of him losing still. Because either way, if he doesn't make any of them or if he only makes one of them, he's still going to lose. What about in sending them to overtime? How would he send them to overtime? Well, he'd have to make 2 of the 3 shots. So he'd have to make the first 2 and miss the third. Or he'd have to make the first, miss the second, and make the third. That would also send them into overtime. Or he could miss the first and make the second and the third. That would also, again, send him into overtime. So all of these options are a possibility. But you might think, okay, so there's 8 options. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 options. So you're thinking, oh, well, there's an 1 out of 8 chance that he's going to win the game. No. Because each of these isn't equally likely, right? He has a 72% free throw average. Do you think that it's equally likely that he'll make all 3 and that he'll miss all 3? Like, those are going to be 2 different things. So let's figure out what the probability of each of these things happening is. So the probability of him making all 3, well, what's the probability of him making 1? The probability of him making 1 is 72%, so we have 0.72. And then that's times 0.72 and times 0.72. If I multiply all 3 of those together, that's going to give me the probability of him winning. So that's a 37.3248% chance. Okay, so about a 37.3% chance that he's going to make all 3 of them and win the game. Okay, what is the probability that he will go into overtime? Let's go to that one. Well, each of these, let's see, he has a probability of 72% for making each of the ones. And then what is his probability for missing? Well, that would be 28%, right? Because it's the complement of that. So the first one, 72, 72, 28, 0.72, 72, 0.28, we're going to get is equal to 0.145152. Okay, so about 14.5% chance that he's going to get this first option right here. But what's the percent chance of this one? Well, it would be the same thing, right? Because it would be 0.72 times 0.28 times 0.72. They're going to be in a different order, but we're still going to end up with the same number. 45152. So we're going to have this 3 times, right? So this is a 0.28 chance, probability, I should say probability. So in the end, what is the actual probability of him going into overtime? Well, it would be all 3 of those added together. So we're going to multiply it by 3. And we actually have a 43.55% chance that it's going to be sent into overtime. So what's the chance that they're going to lose? Well, the first one, the probability of the first one would be 0.28 times 0.28 times 0.28, right? Because that would be the probability of him losing every single one. So we're going to 0.28 cubed. That is about a 2% chance, actually. He's only got a 2.1, 2.2% chance that that's going to happen. And then what's the probability of the other ones happening? Well, again, it'd be 0.72, and then this time would be 0.28 times 0.28, because the probability of him making is 0.72 and the probability of him missing is 0.28. So 0.72 times 0.28 times 0.28, and we end up with about a 5.6% chance. And how many of those do we have? Well, this is a 5.6% chance, and this is a 5.6% chance, and this is a 5.6% chance. So we need to add all three of those together and the 2.2% chance to find his chance of any of these happening, right? So we're going to multiply that by 3, then add it to our other percentage, and we get about a 19% chance, 19.1% chance that he's going to lose the game on the free throw line.